that potential energy refers to possible energy, while kinetic energy refers to actual energy. Potential energy measures attractions and repulsions. When there are more attractions that occur, there is less possible energy. When more repulsions occur, there is more possible energy. In reference to the Earth, which position would be associated with the greatest possible energy? That is, the lowest attraction to the Earth. It obviously would be a position that is farthest from the Earth. In reference to the nucleus, which position would be associated with the greatest possible energy? That is, lowest attraction. It would of course be the position that is farthest from the nucleus. Again, in reference to the Earth, which position would be associated with the lowest possible energy? That is the greatest attraction to the Earth. Of course, it would be the position that would be closest to the Earth. And again, in reference to the nucleus, which position would be associated with the lowest possible energy? That is the highest attraction. It would of course be the position that would be closest to the nucleus. Here we must understand that the energy levels of electrons correspond to specific distances that the electron takes in reference to the nucleus, with the energy level 1, or n equals 1, corresponding to the 1s sublevel, and energy level 2 corresponding to 2s and 2p, and energy level 3 corresponding to 3s, 3p, 3d, and the fourth energy level corresponding to 4s, 4p, 4d, and 4f. In reference to our previous discussions concerning the size of different atoms, we recall that, all other things being equal, if a nucleus has more protons, there will be a greater attraction to the electrons, and the electrons' energy levels will be drawn closer to the nucleus. Here we see that beryllium is much smaller in size compared to lithium. Thus, we can now ask which energy level is more attractive, that is, has lower potential energy than the other, the first energy level in lithium or the first energy level in beryllium. It is clear that since the first energy level in beryllium is brought closer to the nucleus, it definitely has a greater attraction and thus lower potential energy for those electrons. And since boron is brought closer through attraction, the boron has a lower potential energy in its energy levels as well compared to beryllium. And the pattern continues across the period, with more protons resulting in greater attraction and those electrons being drawn closer to the nucleus, resulting in lower and lower potential energy for those electrons. However, as we can clearly see, when a new energy level is begun, that electron exists substantially farther away from the nucleus. Thus, that electron is much less attracted to the nucleus and has much greater potential energy. Thus, potassium's outermost electron in the fourth energy level is much less attracted and has greater potential energy than the electrons in argon's third energy level. And rubidium's outermost electron in the fifth energy level is much less attracted, has greater potential energy than the electrons in krypton's fourth energy level. Finally, as we go down a group, we note that because there are more energy levels of electrons around the nucleus, the outermost electrons are less and less attracted to the nucleus and thus have higher and higher amounts of potential energies. The takeaways from this video are as follows. With greater nuclear charge across a period, the effect for the electron will be less and less potential energy. This is because of the greater and greater amounts of electrostatic attraction to the nucleus, and this corresponds to the decrease in size. However, once a new energy level has begun, the effect of the electron is to increase its potential energy. And this is because it is much less attracted to the nucleus because it exists farther, substantially farther away from the nucleus. And of course, this corresponds to an increase in the atom size. Finally, as we go down a group, we note that as there are more and more energy levels for electrons, that there will be substantially less attraction for those electrons to the nucleus. And the effect for that electron is to increase its potential energy. Of course, this corresponds to a larger and larger atomic size. Till next time, CHM.